Hello, my name is Bertil Chapuis from University of Lausanne. This research is entitled An Empirical Study of the Use of Integrity Verification Mechanisms for Web Subresources. And this is a joint work with Olamide Omolola from TU Graz, Mauro Cherubini from University of Lausanne, Mathias Humbert from Arma Suisse, and Kévin Huguenin from University of Lausanne. So today, we're going to discuss about sub-resource integrity. We're going to see why it's an important topic on the web today. And during this presentation, we'll first start with the system and threat model. We'll then discuss the sub-resource integrity recommendation from the W3C that can be used to thwart the threats. We're going to discuss a large-scale analysis that we achieved with big data processing, a web developer survey that we conducted, and finally, we will discuss some conclusions and takeaways. So let's start with the system model and consider a web page stored on server.com. Here, the web page is index.html. And the HTML code of this web page goes a bit like this. First, we have a title, welcome, and then we have a couple of sub-resources. Here, first, we have a script, which is located on the same server. And then we have two external sub-resources, a link and image, which corresponds to a style and an image, and they are located on an external server, otherserver.com. So when a user visits this web page, the browser fetches this web page, and it also fetches the sub-resources on the same server, but also on the external server. So what could possibly go wrong? First, we may have an attacker on the first-party server, our server. So in that case, there is not much we can do except maintaining it, keeping it up to date, and protecting it as much as we can. Second, there are some attackers that may attack us on the communication link. In this case, we usually set up HTTPS to protect ourselves from these attackers. And finally, we may have an attacker on the third-party server, and we are really interested in that one today. And the sub-resource integrity recommendation is really used to thwart this kind of attacker that may harm us from a third-party, an external server. So what could this attacker actually do? He could start corrupting sub-resources, and this would create a number of threats. For example, he could replace content in the web page, resulting in website defacement, for example. He could start injecting malicious JavaScript that will, for instance, access user credentials, record keyboard events, and so on. And here, we are not just talking about blogs or small websites, but we are also talking about corporate websites that commonly integrate such external sub-resources. And they even do so on login pages, payment pages, and so on, giving access to very sensitive information such as credit card numbers. And this is not a fantasy. It actually happened to British Airways, who got hacked through the inclusion of a third-party JavaScript file that they trusted but got modified by the attacker. So how to mitigate these threats? The SRI recommendation, sub-resource integrity recommendation from the W3C comes to the rescue. And this recommendation lets web developers specify an integrity attribute for sub-resources. So this is this attribute here. And this attribute enables user agents to verify the integrity of the sub-resource before loading them. And the sub-resource is loaded according to some rules. So this integrity attribute is supported for the link element and the script element. And an integrity attribute contains one or multiple space-separated hash expression, and it's composed of the name of the hash algorithms used by the web developer and a base64 encoded digest as depicted here. So what are some of the rules that the browser used to load the sub-resource? First, when the attribute contains a single hash expression, the sub-resource is loaded if it matches it. When the attribute contains multiple hash expressions, generated with the same hash algorithm, the sub-resource is loaded if it matches one of them. When the attribute contains multiple hash expressions generated with different hash algorithms, the sub-resource is loaded if it matches one of the hash expression with the strongest digest. And finally, if the integrity attribute is empty or malformed, the sub-resource is loaded nevertheless. And I insist on the last one. Personally, when I realized it, I found it particularly counterintuitive. I would expect such a sub-resource not to be loaded. And as we're going to see later, I'm not the only one in this situation. So let's dive into the study of SRI with the large-scale analysis and the user survey targeted at web developers. And we will start with the large-scale analysis. So to conduct our survey, our study, we used two data sources. The first one is Common Crawl, which is a very large data set. Usually you have about 3 billion web pages in a snapshot, and we used 7 snapshots in the paper, and now we included others. We have 13 snapshots in the result depicted in these slides. And this snapshot spans from 2016 to 2019. And to identify the most popular web pages, we use the second data set. It's the Cisco umbrella data set, which is basically a top 1 million ranking of the most popular domain names, which is computed from the DNS statistics collected by Cisco. So regarding our methodology, first we created a random sample of the web pages in Common Crawl to basically study sub-resources in general, with or without the integrity attribute. And then we created a subset of Common Crawl, which contains all the web pages containing at least one sub-resource with an integrity attribute. So we can really focus on the topic of interest. And to do that, we used Amazon Elastic MapReduce and Amazon S3, PySpark, Beautiful Soup, and LXML. So I must also say that here our study is based on raw static web pages, and sometimes scripts are injected in web pages afterward by the scripts specified in the HTML. So these scripts are not considered in our analysis. We actually performed some small experiment to see how many of these scripts are injected after loading the page. However, doing this at a very large scale would be very expensive. So it's out of the scope of today's study. So regarding the result, first we collected statistics about the use of HTTP and HTTPS. And today, almost 60% of the web pages in Common Crawl and about 90% of the top 1 million web pages are served over HTTPS. This is really impressive. And this is probably due a lot to Let's Encrypt, and which provides free certificates. And it also helps at automating the renewal of the certificates with the ACME protocol. So the key takeaway here is that Let's Encrypt, the free certificates, and the automations really helped at adopting HTTPS. So now if we focus on sub-resources, in 2019, we have about 82% of web pages that have at least one external sub-resource, 54% of web page displaying at least one external image, and about 3.4% of web pages having at least one external sub-resource with integrity. So this is a modest adoption. But how this adoption evolved over time? Another question is, did we already observe what we may call a Let's Encrypt ACME moment for SRI? If not, what could be done to actually achieve it? So to understand the nature of the sub-resources included in web pages, we first devised an heuristic to identify them from the URL in the 1% sample of Common Crawl that we created. And this heuristic, which uses URL to identify sub-resources, is further described in the paper. Here we see the most popular sub-resources that we identified. And unsurprisingly, the sub-resources associated with the Google ad network are used a lot on the web. So in the case of the Google ad network, SRI hardly applies. Why? Because these sub-resources are what we may call add-ons, in a sense that they evolve constantly and independently from the web page, as their aim is to track the users. Similarly, we have some sub-resources that are associated with platforms that hosts websites such as WordPress. We also have Blogger here. And finally, we have sub-resources corresponding to libraries such as jQuery and Font-Awesome or Bootstrap. And these kind of libraries fully benefit from SRI. They can really be used in conjunction with SRI. So as we can see here, SRI is not a universal solution. It's not a silver bullet, as some sub-resources must evolve independently from the websites. And this is still an open problem, which is actually not covered by the SRI recommendation. So here we depict the proportion of web pages in Common Crawl that contain at least one sub-resource with an integrity attribute. And what we can notice here is that by the end of 2019, about 3.5% of web pages contained an integrity attribute for a script or link. And this adoption is modest, but as shown in the figure, it's increasing. So this is encouraging. Here, we show the distribution of the hash algorithms used in the integrity attribute. And the most popular is SHA 384. And the possibility of an integrity attribute to contain more than one digest is rarely used in practice, and we can observe it here. Finally, we also notice that only about 2.8% of the integrity attributes are empty or malformed, meaning that these sub-resources we have here will be included in the web pages, which is somewhat counterintuitive. So this figure is based on the set of web pages that contain at least one sub-resource with an integrity attribute. And for these web pages, we compute the average number of sub-resources in general on those who has an integrity attribute. And these two average have a large discrepancy with an average of about 40 sub-resources per web pages and about 2 sub-resources with an integrity attribute per web pages. So over time, this difference remains approximately the same, meaning that we don't observe a change in the way sub-resources with integrity are included in web pages. For instance, if the integrity attribute was added automatically by a web framework or a build tool, all the sub-resources would have an integrity attribute. And this is not the case here. So SRI is not used systematically. And in general, web developers are probably copy-pasting code snippets for popular libraries in their web pages. Here, we depict the categorization of sub-resources with an integrity attribute per web page protocol, per sub-resource protocol, and finally by locality, by host locality, in the sense that these sub-resources can be on the same server or on an external server. And in most cases, what we can notice is that SRI is used correctly. Even this case is valid because an upgrade from HTTP to HTTPS for sub-resource is allowed. Finally, we show here the evolution of the top 10 domains targeted by sub-resources with an integrity attribute. And here we can notice that most of the associated websites are actually websites corresponding to CDNs, which provides code snippets such as Font-Awesome or Bootstrap. And here, what's also interesting to notice is the case of Shopify, which is the first result, and which corresponds to a hosted platform to build e-commerce websites. And in their case, they probably make use of automation to add integrity attributes, which shows that it is possible to do that at a very large scale. But in general, people are more using copy-paste and snippets from CDRs. So the key takeaways are the following. First, we noticed a modest but increasing adoption of SRI. We saw that this adoption seems to be driven by a copy-paste behavior. We also noticed that automating the computation and inclusion of the integrity is possible at scale with the example of Shopify. However, we have not been able to observe what we may call a let's encrypt ACME moment in the data yet. So in order to drastically improve the adoption of SRI, it is key to better understand web developer experience when using the SRI recommendation. And to achieve this, we conducted a web developer survey. So when thinking about it, we devised 4 research questions. The first one was, are the web developers aware of the risks associated with external sub-resources? The second, are web developers aware of SRI at all? The third one, to what extent do web developers understand the implementation of SRI? And finally, what are the current practices of developers when using SRI? So this online survey had a duration of about 10 minutes. It contained open-ended and closed-ended questions. And to motivate the participant, we did a raffle for $100 Amazon vouchers, and we recruited the participants via emails. We recruited WordPress plugin developers and NPM package authors. They usually provide their emails in their repositories. So we collected them and we reached out using these emails. And out of this survey, we collected 477 responses. And we applied some quality assurance filters to ensure that the responses were complete and that we had removed speeders and straighteners. And we ended up with 227 valid responses. So now, the first question was, are the web developers aware of risks associated with external sub-resources? And to assess this, we asked an open-ended question to discuss the potential threats that could affect a website if external sub-resources were loaded. And here, 56% mentioned that the main threat, in other words, malicious code injection and cross-site scripting. So this is quite encouraging. They really identified that the attacker was the one on the third-party server. 13% mentioned the secondary effects, which is also encouraging, keylogging, compromised user privacy, and so on. And about 30% provided generic answers, non-applicable responses, or had no ideas about the possible risks. So 1/3 we did not understood the issue. For the second question, are web developers aware of SRI? So we again asked an open-ended question asking to list the possible solutions to protect websites from the aforementioned threats. And here, 50% provided non-applicable responses. 30% provided mostly correct answers. Either they mentioned integrity verification mechanisms or the sub-resource integrity recommendation from the W3C. Finally, 18% mentioned unrelated security mechanisms such as two-factor authentication, which is a bit worrisome. So for the third question, to what extent do web developers understand the implementation of SRI? We asked a couple of closed-ended questions with first this one. Is it meaningful to use sub-resource integrity if the target is served through HTTPS? And here we noticed that 86% provided the correct answer. So they clearly understand that the problem is not on the communication link, but on the third-party server. The second closed-ended question was what happens when an integrity attribute has 2 or more valid hash values created with different algorithms. And here, 20% provided the correct answer. In other words, it loads only if the strongest digest matches. And about 45% and 35% were either not sure or simply provided the wrong answer. The third question was, what happened when an integrity attribute has 2 or more valid hash values generated with the same algorithm? And here, 28% provided the correct answer. It loads only if any digest matches. But what's a bit worrisome is this 4% who said it loads only if all the digests match. In other words, you would need to find hash collisions for the resource to load, which would be very expensive, but shows that these 4% have not been exposed to integrity verification mechanisms. And finally, what happens if the digest in an integrity attribute is malformed? For example, if we have an unsupported hash algorithm, or if the digest is non-base 64 encoded. And here, we see that only 6% provided the correct answer. It loads in any case. And as mentioned earlier, I found this really counterintuitive, and most of the surveyed web developers think the same. About 72% felt in the trap. So this aspect of the recommendation is really counterintuitive. So now if we compute the survival graph for these 4 questions, we notice that almost 60% of the web developers answered correctly to 0 or 1 question out of 4. So there is clearly some effort that should be provided to help them getting a much better understanding of the recommendation. So the 4th question was, what are the current practices of web developers when using SRI? So it was a closed-ended question. And we also had open-ended questions asking to list practices when including subresources with an integrity attribute. And here, 45% of the developers acknowledged that they copy-paste snippets from trusted sources such as online documentations. 38% said they were using build tools to automate the computation of the integrity attribute. As shown in the large-scale analysis, we haven't been able to observe this on the web. So this is probably either due to the fact that we reached to specialized web developers who already published the package, so they are better than the average, or they picked this option because they believe it would be the ideal solution. We notice as well that about 20% declare computing the integrity attribute manually, and 10% said they copy-paste these snippets from online community, for instance, Stack Overflow. And given the fact that a malformed integrity attribute gets included in the web page, this is a bit worrisome because such sub-resources could give a false sense of security. So the key takeaways for the web developer survey are the following. First, SRI is somewhat misunderstood by web developers. The adoption of SRI is driven by a copy-paste behavior, and a few solutions are actually available for automating SRI. When we asked web developers if SRI should be extended to other elements, HTML elements, 66% said it would be a good idea. 83% believe that it would be great to have it for images, and 67% said they would love to have it for links that would help protecting web downloads on binaries that people download from the web. So the adoption of SRE overall is modest and driven by a copy-paste behavior. We also saw that the adoption of the automation of SRI would be an ideal solution, but it's not common yet. In this regard, we haven't been able to observe what we may call a let's encrypt ACME moment for SRI. This would have already resulted in a majority of sub-resources with integrity in web pages, and we haven't been able to observe it. So SRI is not adapted to sub-resources that are updated independently from web pages. And we also said that as of today, there is no mean to protect yourself in that case. So this is still an open question that may be also covered by another specification or recommendation. We also noticed in the survey that SRI is rather misunderstood by web developers. And finally, we saw that web developers would also be very interested in an extension of SRI to other kind of sub-resources, such as images and downloads. So regarding the future work, what we would love is first improving the awareness and understanding of SRI. For instance, should the recommendation be revised in order to be more intuitive? Or can we improve the understanding of the mental models associated with SRI? We would love to investigate the automation of SRI, for instance, with solutions that are highly independent from the software stack and the build tools. The question is, would it be possible to devise a solution that works independently from the software stack? So we don't target simply a small community associated with a framework, but the whole web development community. And finally, we would love to see SRI being extended to some other types of sub-resources. In particular, we think that providing SRI for downloads would be an ambitious technical goal, but really useful as many people still download binaries and executables on the web. So thank you very much for listening to this presentation. I will now be available for questions and answers on Zoom.